last but not least, we have Neil. So Neil is working on the drum sequencer, and he's actually really passionate about his project. He actually plays drums at home. So as someone who's played an instrument for the past 15 years, I can appreciate that. Usually the problem we have with students is finishing their project, but for Neil, his problem was finding something to do. So I remember on a ton of different occasions, he was like, Brian, I'm done with X, Y, Z. What should I do now? I said, all right, go work on your portfolio. All right, I'm done with that. What do I do now? Your notebook. All right, I'm done with that, which wasn't always true, but most of the time you did a notebook. All right, what's next? I'm like, all right, dude, just go to J9, practice your demo, get out of my face. I need to help someone else. Go find something to do. So he's been super passionate, super productive, and I'm really happy to say that he's here to show everyone your project. So give it up for Neil.
Hello everyone, my name is Neil and I'm from St. Francis High School, and this is my project, the 16-step drum sequencer. Just so you know, this image is flipped because this is the way the photo booth works. But I chose this project because I've been playing drums for the past 8 years. I played at school in my concert, marching, and jazz bands, and at home as a hobby. And I wanted to make a way that you can make clean, high-quality beats simple and through digitally rather than hooking up your drum set to microphones or having to get professional audio recording software. I also wanted to do a project that was more hardware focused, so more wiring, soldering, more stuff rather than coding, since I already knew partially a lot about that. So the way this 16-step drum sequencer works is this is the start and this is the start. This is the start and stop button. This is the menu button, and these 16 switches represent 1/16. So if I press this button, it cycles through these 16 switches. And you see these illuminated switches. When this instrument is displayed right here, it says bass right now, but the currently illuminated switches right here are playing a bass sound when they're when passed upon in the sequence. And if I move this knob, you can see all the different instruments. It's inverted, but this says high tom, clave, cymbal, clap, and each of the illuminated ones show when it plays. In the menu, there's a tap mode, save, load, clear, and default. So the tap mode is basically each of these switches is assigned to one sound. So if I press one of these sounds, each one is assigned to one, so you can play a beat like by itself. And then it just allows for more complicated beats that don't stick to that structured 16-note pattern. And just so you I'm clear, a 16th note is just 1/4 of a beat. So a beat is just how many times it's played in a minute. And the inside of this box looks kind of like this. Kind of looks, there's a lot of wires and a lot of tape. The tape I'm not really proud of, but the wiring also needs some work. But instructor in the other room, Nazar, he inspired me to actually make it neat rather than wires just going all over the place. And one of my modifications for this thing was the casing. So by itself, it used to just be a breadboard, just the thing inside, and no 3D printed case. But I added a case and I catted it in Fusion. And another one was the saving and loading feature. So to save, you would have to send data through a serial connection to this computer, and it would save it on a JSON file. A JSON file is a file that is just easy to access, to load, and save data. And my last modification was the tap mode, which I just showed you. So when you press a switch, it's assigned to a specific sound. One of my challenges was the wiring. As you can see here, it looks like a minion. Not that hard to trace back to its source. So that's something I could improve on in the future. Like, imagine just picking a wire and seeing where it goes. Not very easy. Another thing I had to do was the soldering. So each of these joints here was soldered, like all these little, there's 5 per on each side. So they had to be soldered. And I made a lot of mistakes with that. There would be joints connected. Some I forgot to solder somehow. And then also on the two switch boards on the top, I also forgot to solder some stuff. So I also had to learn how to CAD. The CADing took me at least 2 days for the first prototype, which is not that efficient. But once I got better at it, the final prototype only took like 2 hours. And for my what I learned here, I learned a lot about wiring and soldering. I knew almost nothing about circuits. And I had to learn what a ground was, which is kind of basic, but it's kind of necessary to know. And I also had to, I learned CADing too. The next steps for this project were to make it self-sufficient, so it wouldn't need this computer right here. It could just be by itself with its own speakers and probably run off of a Raspberry Pi or a MIDI controller or something like that. Thank you. Do you guys have any questions?
Have you tried programming to play along with any song?
Yeah, that was one of my ideas for later, to load a song onto here so you could try to follow along with the song and try to make something on top of it. Any good questions?
How are you able to like sample sounds? Like, oh, if I play this key, I want this sound to play versus like another one.
So the GarageBand on the MacBook has all these sounds preloaded. So you send a note, which is corresponding to that sound, to GarageBand, and it would play it. That's the reason the self-sufficient one is a little hard, because it's hard to find something that could have such a wide library.
You potentially record yourself.
Yeah, I could add my own sound files. Yeah. Okay, thank you.